All right. So we are in the last class of RIP, Routing Information Protocol RIP. After this, we'll be getting into a protocol called EIGRP. Now, we had a similar topology with a packet tracer. Here we are in GNS3 so that I can show you using Wireshark. You see, these routers are running RIP, but I'm not going to tell you what version. From the Wireshark, you only will tell me. Let's see. I'm going to right click here and capture the packets between router 1 and 2. And you see already some feeds are coming in. From these feeds, tell me what version of RIP I'm running.
So the broadcast is 2.5. It's version 1.
Perfect. It's version 1. Even here also it says protocol version V1. RIP V1.
I don't know the correct thing. I just saw the broadcast.
Very good. That is the right way. That is the right way.
Okay.
So it is sending to a broadcast address. Only version 1 will send to a broadcast address. Now, what port number RIP uses? UDP 520. Okay. You see, RIP uses UDP 520. Don't forget, RIP uses UDP. And then when you go down, RIP is advertising this network. You see, 1.1.1.1. RIP version 1 update. And the metric is 1. And do you have any subnet mask information here? No. There is nothing mentioned about subnet mask. Why? Can you answer why it is not advertising subnet mask? You don't know? You know or you don't know?
It does layer 3 broadcast.
See, because it's a layer, no, because it's a version 1 classful protocol. Version 1 is what protocol? Classful protocol. It will not send the subnet mask. What is classful? They don't understand subnetting. If it finds if it finds the first number as any number between 1 to 126, it assumes as /8. If it is 192.168, it assumes as /24. So they don't really need a mask because they don't understand classless prefix length. They do only understand the default mask. So they don't advertise mask. There is no need to advertise mask because this is classful protocol. Now what I'm going to do is I'm going to quickly change to version 2 and then I'll go back and show you. On router 1, I'm going to change saying router RIP version 2. Similarly, I'll do it on router 2. Router RIP version 2. Likewise, I'll go to router 3. Router RIP version 2. Also in router 4. Router RIP version 2. So done. Now let us go back to router 1 and see some update. Look at this. You started seeing multicast 224.0.0.9 and you also see here it says version 2. You see even the color is good. When it was a broadcast packet, it was red in color. See up all red, 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 because broadcasts are considered bad. Now I'm going to click router 1, and you see the same router which was advertising without subnet mask, now it advertises with subnet mask. Now let's see one update coming from router 2. Router 2's update. You see router 2 is sending a lot of network. Router 2 says 4 network is this is the mask. By default it will summarize, that's why it is this mask. Actually it is 32, it is summarized. If I go and say no auto summary, see, no auto summary, now you check another update, the new update that is coming, okay, from router 2. I'm looking for another fresh update to come. I have said no auto summary. I'm expecting now here 255 as the mask in the next update from 10.0.0.2. Every 30-second update will come. Now still I'm seeing 255. Let us also go to the middle routers and say no auto summary. On router 3, no auto summary, so that it will send the actual mask. Router 2. Okay. Now go back to Wireshark and see. Look at this. You see, without summarizing. It is sending without summarizing the detailed mask. So it will be sending periodic update. This is triggered update, only the change it has sent. It will be soon sending the periodic update. What is this number 3? It's the hop count. It's a metric. Okay, now you see for 4 network, this is the mask. And for 20 network, this is the mask on the interface, that is right. For 30 network, this is the mask. And this is the hop count. Right, this is how the RIP update will look like. Alright, so let us close this. Now what is next? Let us say you want to have version 1, also version 2 on one of the router. For example, you want to have version 1 on this side, and on this side you want to have version 2. You know why? The reason is this router don't have version 2. Assume. Just I'm asking you to assume. You don't have this router with a newer operating system. That router is a very old router. And that router don't support version 2. This is only version 1. So between these two you want version 1, and between these you want version 2. How can we do this? Answer is we can do this. It's not that we cannot do it. We can do it. How? First of all, I'll make this as version 1 only. Go to router 1 and I'll say version 1. It's version 1 now. Okay, next. On router 2, I need to go to this F00 interface. Currently, if I go to router 2, listen carefully, debug IP packets. Right now, if I go to router 2 and put this debug, it is going to say sorry, not IP packets, debug IP rip. It is going to say whatever is coming from router 1 is the illegal version. Router 1 is in version 1, version 2 is in version 2. Sorry, router 2 is in version 2. So router 2 is going to say the update coming from version 1 is an illegal version. I'm going to show you. It will come soon. Look at this. I'm ignoring version 1 packet that is coming from 10.0.0.1, which is router 1, because it's an illegal version, which means it is not ready to learn anything from router 1. We should make this to learn. How to make it learn? Go to F00 interface of router 2. Go to F00 interface and say this command: IP rip receive version 1. IP rip send version 1. You see, we do have this option. So router 2, basically it is version 2, but only to this direction, on F00 direction, it is going to behave as a version 1 router. So we will see now broadcast coming from router 2. If I capture again and show you, you will see now broadcasts. You see, from both the router you are getting only version 1. Yeah, but if I capture here, let me stop the capture here, and I'll close this one, and I'll start capturing here. Between these two, it is still version 2. You see, you will see 224.009 coming now. I'm waiting. You see, it's version 2. You got what I'm saying? We can have interface level configuration of versions. Okay. Now, what is the administrative distance of RIP?
120.
Yes. We can change it. How can we change it? Let me go to a router and show you. On router 2, router RIP distance is the command. The default is 120. If you want to change it to 75, you can do that. Now let us go and verify whether the change has happened. Show IP protocol. This command will show you. You see, it says the administrative distance is 75. Now I'll go and cancel it so that you will see the original one. See, if you cancel it, automatically it will go to the original one. Original one is 120 as you said. Let's go and check now. Look at this. All right. Now what is next? You see right now, show IP route. I'm learning the route 4444 network, which is on router 4. I'm also learning 30 network, which is in between 3 and 4. I don't want router 2 to give these things. I repeat. I don't want router 2 to give these routes to router 1. But I want router 1 to learn whatever router 1 gives. I want router 2 to learn whatever router 1 gives. I repeat. This should not give any update, but it can learn, it can receive updates. You understand? What is the option to achieve this? We have something called passive interface. Passive interface. How do we do that? Go to router 2 and say router RIP passive interface is F0/0. That's it. If you say this command, that interface, via that interface, no updates will be sent. I want you to watch closely now. See the timer. Every 30 seconds, the update should come. See the timer. It is 17, 21, 24, 25, 26, 27, 28, 29. Oh no, what do you understand from this? Oh no, I'm saying oh no. What do you understand from that? It means updates are not coming. If it is coming, it won't go more than 30. If every 30-second update comes, it will not go more than 30. But here it has gone to 40. Let me show you that. On R4, go and check. Show IP route. You see this one, it won't go more than 30. 08, 11, 14, 17, 20, 21, 23, 25, 27, 28. Look at this. From 28 it jumped to 01, which means update has come, so it got refreshed. But whereas in router 1, it has even reached 1 minute 28 seconds. What does it mean? Updates are not coming from router 2. Why it is not coming? Answer. You have to answer this.
Because it's passive now.
Passive.
Interface is passive.
Router 2 is not giving. Now, how long this route will be in the routing table? We learned that it will be there for 180 seconds, isn't it? After that, it will become possibly down, and in the 240th second, it will be removed. That's what I'm trying to show you. After 240 second, after 180 second, it goes to possibly down. And then it will start advertising this network with the hop count of 16. What is 16? Infinite metric. Why it is advertising 16? So that everyone will know that this network is no more available. It will advertise with 16. That is what called as route poisoning. In RIP, it is called route poisoning. After waiting 180 seconds, say when it reaches 60, now it is 49. When it reaches 60, I want to quickly go sniff the packet. Oh, come on. I should have done it a bit earlier. It will start sending with 16 hop. Now let's see the timer. Look at this. It is possibly down. These networks now should be advertised with 16 hop so that others will know that it is poison. See, I'm opening and showing you. Look at the 16 metric, 16 metric, 16 metric. What it is called as? Route poisoning. It says that I have waited for these 3 updates. It never came. So, anyone is receiving my update, you should know that these networks are no more. This is called route poisoning. For 60 seconds it will be saying this, and it reaches 240 seconds, then it gets removed. Okay, so see, gone now. 240 seconds after that it should be removed. It got removed. These networks are no more. Did you understand route poisoning? Please answer. You're the only one in class. I need to answer. Do you understand route poisoning?
Yes, sir.
Okay. After waiting 180 seconds, it starts sending all those routes which is not receiving update with hop count 16, and then after reaching 240 seconds, it removes the route also, sending 16 hop instead of 2 hop or 1 hop. Instead of a valid hop, when it sends the infinite hop, infinite metric, we call it as route poisoning. Right?
Okay.
Okay.